Hi, this is Dave Savastano again with Print Electronics Now. For our next speaker, I know him well, Doug Hackler, President and CEO of American Semiconductor, has done some tremendous work in the flexible electronics space, and he's going to talk to you about state-of-the-art and issues for Bluetooth FHE. Doug, here you go. And oh, by the way, if you have any questions, folks, please post them in the chat, and we will get to them right after the talk. Go ahead, Doug. Thanks.
Well, thanks for the introduction, Dave. This morning I'm speaking to you from Boise, Idaho, USA. It's a beautiful spring morning here, sunshiny and warm. And I'm happy to be talking to you about the state of the art for flexible hybrid electronics as specific to Bluetooth and some of the issues that we face with ultra-thin assemblies of Bluetooth capabilities. So jumping into it, the first slide hits to the motivation for doing this work, and that's a macro trend that's being termed Thinnerization, and that's making systems thinner and more pliable, and certainly it applies to Bluetooth. And we see some examples of that here. Things like earbuds, where you're trying to put Bluetooth capability into a very, very small package, oftentimes can benefit from having the ability to have the flexible circuit board or the chip bend or conform into very small places. Not used in this technology, but it's the kind of capability that will allow this technology to move forward into more convenient or alternative sizes for use. Likewise, in towel trackers, you can see here the credit card size or the key fob size, like the Apple AirTag. And you can imagine that these things right now that are in very small, rigid cases, they are getting thinner, and the thinner they get, they're harder to keep rigid. Right now, rigidity is a requirement for reliability. But if we did away with that requirement for rigidity, making these ultra thin and flexible, then those formats become even thinner than they are now and allow more reliable use of Bluetooth in these applications. And of course, there's things that are wearable, like the sleep headphones on the right. And you can see there that the trend toward thinner makes that product a lot more comfortable to wear. But if you can really make it thin and make it flexible, then it would make the product be as comfortable as the material that's embedded in. So this trend of Thinnerization is certainly applicable to where we see Bluetooth going in the future. Thinner, and in the future, even flexible. When we talk about the word flexible hybrid electronic systems, if you're not familiar with FHE, here's an overview of what it looks like. On the left, we start out with a flexible circuit board. A flexible circuit board provides the same function as a printed circuit board you're used to seeing in conventional electronics. And we take that circuit board, and then we need to populate it with the integrated circuits or the capabilities that make it functional. In this case, we take very thin, very flexible performance silicon chips packaged in semiconductor on polymer, and we'll talk more about that in a moment. But when we put the two together, then we take the high performance chips, put them on the flexible substrates, we get a fully flexible system, and that is a flexible hybrid system. In this case, the one that's shown here in the middle is the ultra thin flexible Bluetooth module, which is development board that's enabled to help enable the Thinnerization of flexible hybrid electronics. So like I said, I'm speaking to you from Boise, Idaho, and so just a little bit of introduction to our company. We are American Semiconductor, an industry leader in ultra-thin advanced packaging. And our focus here in Boise is that we develop state-of-the-art ultra-thin electronics technology. And the facility you see there, that's where I'm speaking to you from today. And we maintain an R&D lab here for flexible hybrid electronics, as well as our clean rooms for wafer-level chip-scale packaging, testing, and semiconductor assembly. So we're working to commercialize this semiconductor on polymer technology, which is the semiconductor, the chip packaging technology that makes these ultra-thin silicon chips like the one used in the Bluetooth module. So speaking of that, so what is this semiconductor on polymer? You can see here what the packaging technology looks like. SOP is a chip-scale packaging technology for integrated circuits that makes the thinnest chips possible. You can see a conventional SoC